There are four ways of solving systems of equations. We've already focused on graphing, where you graph two lines and you find if they intersect, and if they do, what that ordered pair is, if they're parallel, or if they are the exact same equation, in which case we say they have infinitely many solutions. I also showed you how to use the intersect function on the graphing calculator to find the point of intersection. It's a great way to do the problem, particularly when the answers are decimals. But there are some algebraic ways of solving systems, and in Algebra 1, the first algebraic method we learned was to solve using something called substitution. The way substitution works is you need one of the two equations to be solved for a variable. Well, I want you to notice that in the second equation, there's a 1y. That's important because it says that I can solve that equation for y in one step. Now I have an equation that says y equals. I could have easily made an equation that said x equals, but I would have been dealing in fractions, and I want to try to avoid that. What I'm going to do is I'm going to take this equation and I'm going to plug it into the other equation in place of the y. The reason is because y is the same thing as negative 2x plus 10. When I plug it in, I'm particularly fond of using parentheses. I think when students don't, they're more likely to make a mistake. So try to remember to use parentheses. Now I want you to notice I have an equation that has one variable in it. Well, now we're back to simple Algebra 1 concepts. Distribute, so you get 3x minus 8x plus 40 equals 12. Combine like terms. Negative 5x plus 40 equals 12. Solve for x. Subtract 40, so I get negative 5x is equal to negative 28. This is not looking right. Nope, it is. And then I'm going to divide by negative 5. And I'm going to find out that x is equal to positive 5.6. Now that I know what x is, that's only half the answer. Remember that the solution to a system of equations is an ordered pair. So I know the x coordinate, I just don't know y. The easiest way to go back and find y is to plug 5.6 back into this equation. However, it actually doesn't matter which equation you plug into. You could have plugged into this equation or this equation in place of x and solved for y and ended up with the exact same answer. But I'm particularly fond of plugging into the simplest formula, or the one that's going to get me to the right answer the fastest. And it turns out that this will get me there the fastest, because now all I have to do is shove this in my calculator and I find out that y is negative 1.2. So the solution to the system of equations using a method called substitution is 5.6 comma negative 1.2. Let's do an application problem now that's going to involve us using substitution to solve it. A music store offers piano lessons at a discount for customers buying new pianos. The cost for lessons and a one-time fee for materials, including music books, CDs, software, etc., are 6 lessons for $300 and 12 lessons for $480. What is the cost of each lesson and the one-time fee for materials? Now you can use whatever variables you want. Sometimes we just use x and y because it's easiest for us, and sometimes we use variables that represent what we're looking for. So one of our variables is the cost of each lesson, so we can say C is the cost of each lesson. And the other variable is the one-time fee for materials. Maybe we can use fee for the one-time fee. So we know that 6 lessons cost $300 and 12 lessons cost $480. So one of the equations has to do with 6 lessons at whatever the cost is, plus the one-time fee is going to be a grand total of $300. Our other equation The 12 lessons times the cost of the lesson plus the one-time fee will cost $480. And look, there's my system of equations. Now, in order to use substitution, we're going to solve one of the equations for a variable. And it doesn't matter which one. For no apparent reason, I'm going to choose to pick the first equation, and I'm going to solve it for f. And the reason I'm going to do that is because I can do it in one step. I could have also solved the second equation for f. It made no difference. I'd end up with the same answer at the end. I'm going to plug this equation into the other equation. So 12c plus negative 6c plus 300 is going to equal 480. Just like in the last problem, I would distribute, but really I'm just distributing a 1, and distributing a 1 doesn't actually do anything to the problem. I'm going to combine like terms. 12c minus 6c is 6c. And then I'm going to solve for f. So I'm going to find out in a moment what the one-time fee is. Subtract 300. 6c is equal to 120. Divide by 6. And c is equal to 20. And I didn't mean the one-time fee, I meant the cost per lesson. And I find out that it is 20. Sorry, let's try that again. This is not 120, that's 180. You have to tell me when I make these mistakes in the videos. Sorry. 480 minus 300 is 180, and 180 divided by 6 is 30. So the cost per lesson is $30 per lesson. Well, now that I know the cost is $30, the easiest way to find the one-time fee is to plug back into this equation. Except I could plug into either of these and get the same exact answer. So the fee is negative 6 times c is 30 plus 300. Negative 180 plus 300. I'm going to find out that the one-time fee is $120. So the cost per lesson is $30 a lesson, and the one-time fee is $120. You don't have to write the real-world problems as an ordered pair, but if you want to, remember that the ordered pair is always written in alphabetical order.